Okay, here's a couple examples. All these examples are in what's called vertex form. Vertex form is probably the most convenient version of a parabola or a quadratic, what we call it. You might just call it x squared. So if you see a letter x and then it raised to the second power, those are parabolas. And in this format, you can find the vertex rapidly. The formula is just opposite same. So it's going to be the opposite of this number here, which is 2, the same as this number, which is -8. So you can find the vertex really quickly. Opposite, same. So this vertex is going to be -7, comma, -5. Opposite, same. So this vertex is going to be -2, 4. Again, opposite, same. So the opposite of -3 is 3, the same as 7. So these are my vertices for these quadratic equations. Now, the number out in front tells you whether it's open up or down. So notice this is a +5, so that means it's going to open up. A negative number opens down. A positive, no number out here, so that means it's +1, that would open up. The negative means it's going to open down. The axis of symmetry is just this number, x value. Just this number, x value, x value, x value. So the axis of symmetry for each of these, I look at the vertex number, x value of 2. So the AOS, or the axis of symmetry, is going to be x equals 2. The AOS is going to be x equals -7. The AOS is going to be x equals -2. The AOS is going to be x equals 3. Okay, these are all examples of standard form. When you're looking at standard form to find the vertex, that's a little bit of a challenge. But what's easy about standard form is that you can find out if it's concave up or concave down. So notice, this is a positive, so that means it's going to be concave up. It's going to open up. This one's a positive 1x squared, so that's going to open up. This is a -2. So that means it's going to open down. So you can find those really quickly. You can also find the y-intercept really quickly when it's in standard form. It's that number dangling off the edge there. So the y-intercept for this is going to be 0, 2. The y-intercept is going to be 0, -1. And the y-intercept for this is going to be 0, 1. And that's sometimes helpful when you're graphing. Now to find the vertex, you want to use this formula called -b over 2a. So -b over 2a is the AOS. And if you want the vertex, you're going to plug that back into the equation. So it's f of -b over 2a. I know that sounds a little confusing right now, but when I do the example, it'll show up a little nicer. So to find the vertex, I want to find the AOS first, which is the x value of the vertex. And that's going to equal -b over 2a. Looking at the equation, this value is a, this value is b, -6, and this value is c, 2. So I'm going to do -b, so that's going to equal -6 over 2 times, and I plug that 2 in. That 2 goes into the parentheses. -6 is +6 over 4. So 6 divided by 4 on my calculator is 1.5. So my x value of my vertex is going to be 1.5. Now to find the y value, that's a little trickier. I have to take that 1.5 and plug it back into the original equation. So I'm going to write this down. 2 times 1.5 squared minus 6 times 1.5 plus 2. I'm going to take that 1.5 and plug it in. So 1.5 times 1.5. 1.5 squared is 2.25. And then I'm going to multiply that by the 2 out front. Times 2. And that's going to equal 4.5. So this first term is going to equal 4.5. And then -6 times 1.5. So I'm going to type in 6 negative times 1.5. And that's going to equal -9. So -9 for my next term, plus 2. So to find out what this second number is, or my y value of my vertex, I have to type in 4.5 minus 9 plus 2. 4.5 minus 9 plus 2. And it equals negative 2.5. For the next example, again, to find the vertex, to find the x value of the vertex, I have to do negative b over 2a. So I'm looking for the vertex, and for this equation, a is 1, b is 4, and c is negative 1. So negative b over 2a is going to equal negative, notice b is 4, so negative 4 over 2 times, and a is going to be 1. That's going to equal negative 4 over 2. So my x value for my vertex is going to equal negative 4 divided by 2, which is negative 2. Now I have to take that negative 2 and plug it back into this equation. So it's going to be negative 2 squared plus 4 times negative 2 minus 1. So I'm going to plug that negative 2 in. So negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8 minus 1. So to find the y value of my vertex, I have to type in 4 minus 8 minus 1. 4 minus 8 minus 1. Negative 5. To find my vertex, I have to do negative b over 2a. So a is negative 2, b is 8, and c is 1. Negative b over 2a, that's going to equal negative 8 over 2 times negative 2. So that's going to give me negative 8 over negative 4. That means my x value, my axis of symmetry, is going to be positive 2. I write this down, negative 2 times 2 squared plus 8 times 2 plus 1. I have to plug this 2 in to the original equation. So 2 squared is 4. 4 times negative 2 is negative 8. 8 times 2 is 16 plus 1. So I'm going to type this into the calculator. This time I'm going to type it from right to left. 1 plus 16 minus 8. 1 plus 16 minus 8. And that would give me 9. So my y value is going to be 9 for my vertex. Let's go over the AOS, the axis of symmetry. My axis of symmetry is going to be x equals 1.5. It's going to be x equals negative 2. It's going to be x equals 2 for this one. But these are some examples of factored form. So you can't see right away that it's x squared, but notice x times x is x squared. A lot of teachers want you to FOIL it out and then distribute the negative 2 and get it in standard form. Sometimes that's the question. They ask you to get it in standard form. Usually when they give you this question, the first thing they ask is it concave up or concave down. So it opens down because it's a negative. This one opens up because it's a positive 3 out front. This is a negative out front, so it's going to open down. Now, it will also ask for the intercepts. The intercepts are really quick. What you're supposed to do is take this x minus 1 and set it equal to 0. So x minus 1 equals 0. You add 1 to both sides. That means one of my intercepts is going to be x equals 1. After you do this enough, you'll notice the answer is just the opposite of what's in the factor there. So this answer is 1. This answer is going to be 3. So I have two x values, two x intercepts, 1 and 3. Another question they'll ask you is what's the vertex? Or what's the AOS, the axis of symmetry? And here's a nice move. Instead of foiling this out and distributing negative 2, all you do is add up the answers. So you're going to add up 1 plus 3 and divide it by 2. You take the average of the answers. So 1 plus 3 is 4, and 4 divided by 2 is 2. So my x value for the vertex is 2. Now, to get the y value, that's a little bit more work. I have to take this 2 and plug it in here, and then evaluate it at the whole thing, because that's going to give me the y value at x equals 2. So I'm going to write down negative 2 times 2 minus 1 times 2 minus 3. So 2 minus 1 is 1. This is going to equal negative 2 times 1. And then 2 minus 3 is negative 1. So negative 2 times positive 1 is negative 2. Negative 2 times negative 1 is positive 2. Let's take a look at the second one. So, its answers are going to be, or x-intercepts is going to be x equals negative 1 and x equals 5. Notice it's the opposite of those in there. For vertex form, it's opposite same. For factored form, it's going to be opposite opposite. That will give you the x-intercepts. These are not the vertices. Now, to find the vertex, you add these up. So I'm going to add up negative 1 plus 5 and divide it by 2. So 5 minus 1 is 4. 4 divided by 2 is 2. So once again, my vertex is going to have a value of 2 up front. Now, to find out what the y value is, I have to plug this 2 into both factors. So this is going to give me 3 times 2 plus 1 times 2 minus 5. And when I evaluate this, it'll give me that y value of the vertex. So 2 plus 1 is 3. So I'm going to evaluate this. This is going to be 3 times 3. And then 2 minus 5 is negative 3. And then I multiply these, it will equal negative 27. 3 times negative 3 is negative 27. So there's my vertex. I'm going to take these values, opposite, opposite, not opposite same. It's opposite same when it's in vertex form. When it's in factored form, it's opposite opposite to get the answers. So x equals 2, that's an intercept. X equals 6, that's the other x-intercept. Now, the vertex is going to be 2 plus 6 divided by 2. So that's going to give me 8 divided by 2. So the x value of my vertex is going to be 4. So if they ask you for the vertex, it's going to be 4 comma some value. Now I have to take this 4 and plug it in. So this is going to give me negative times 4 minus 2 times 4 minus 6. When I evaluate this, that'll give me my y value. So I'm going to say equals negative times 4 minus 2 is 2. 4 minus 6 is negative 2. So negative 2 times negative 2 is positive 4 for my vertex. All right, to find the vertex, that's the lowest point here. I go right 1 and then down 1, 2, 3, 4, 5, 6, 7. So that coordinate is 1 comma negative 7. So the vertex is 1 comma negative 7. The axis of symmetry, that x and that x reminds me that the axis of symmetry is going to be x equals that 1. So that's the axis of symmetry. The x-intercepts are right here on the drawing. So at negative 2, that's one of them. And the other x-intercept is from the center, 1, 2, 3, 4. Sometimes they might have you write it down as an actual coordinate. So it'd be negative 2 comma 0 and 4 comma 0. It depends on what your teacher's asking. The y-intercept, that's where it crosses the y-axis. In this case, it's going to go through 1, 2, 3, 4, 5, negative 6. Where is the parabola increasing? All math arrows point right. Notice how this arrow is pointing up to the left. Actually, arrows on all graphs are pointing to the right. Now, these arrows are pointing to the right and down. Then these arrows are pointing to the right, but up. So where it's increasing is where the arrows are pointing up. So it starts at the x value 1 all the way to infinity. So it's increasing from x is greater than 1. It's usually going to be around where that axis of symmetry is. It's going to break it up from increasing and decreasing. The domain for the parabola is all real numbers. It goes to the left forever. It goes to the right forever. And then the range, the lowest y value is going to be that negative 7 from the vertex. So y is greater than or equal to negative 7. So the range is going to be y is greater than or equal to negative 7. Notice the lowest y value is negative 7, and it goes upward forever. As x values decrease, so as the x goes to the left, the y values go up. Up is positive infinity. All right, again, I'm asked to name the vertex. The vertex is going to be this maximum point here. Notice I go right 1, up 1, 2, 3, 4. So the vertex is going to be 1, comma 4. The AOS, the axis of symmetry, again, that x and that x, they line up, so it's going to be x equals 1. The axis of symmetry is this vertical line that goes to the vertex. The x-intercept is negative 1 and 1, 2, 3. Negative 1 and 3. Again, sometimes we're asked to write it as -1, 0, and 3, 0. The y-intercept is going to be on the y-axis, 1, 2, 3. So that's going to be 3. If we're asked to write that as a coordinate, that would be 0, 3. Where's the parabola decreasing? Again, the increasing, decreasing is going to be given about where the axis of symmetry is. All math arrows point to the right. So these arrows are showing it going uphill. Then these arrows are showing it going to the right, but downhill. So where is the parabola decreasing? To the right of the axis of symmetry. So where x is greater than 1. The domain of the parabola is always all reals. The range from the lowest y value to the highest y value. This time the highest y value is that 4 from the vertex. And then all the y values are less than that. So the range is going to be y is less than or equal to the y value of the vertex, 4. As the x values go to the right, the y values go down. The y values go down. All right, we're asked to write this in standard form. So what I'm going to do first is FOIL this out. Some people do FOIL, some people do a box method. So if you're doing a box method, you set up a cute little box, a Punnett square, and you have x minus 7 and x plus 2. X times x is x squared. X times 2 is 2x. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. Then we're going to combine like terms. So that would give me 3 times x squared minus 5x minus 14. Now I have to distribute the 3 across. So that would give me 3x squared minus 15x. And I wonder what 3 times 14 is. (42). So minus 42. And that's the standard form of number 17. Y equals 3x squared minus 15x minus 42. Again, we're asked to write it in standard form. So this time I have to take the x minus 3 and square it. So I'm going to set up a cute little Punnett square. But this time I'm going to do x minus 3 times x minus 3. So x minus 3 times x minus 3. That's going to give me x squared minus 3x plus 9. So it's going to be negative 4 times x squared. Combine like terms, that's minus 6x plus 9. Close the parentheses because I was only foiling out the x minus 3 plus 8. Next step is to distribute the negative 4. So that would give me negative 4x squared. Negative 4 times negative 6 is plus 24x. Negative 4 times 9 is negative 36. And then I have to add 8. So I wonder what 8 minus 36 is. 8 minus 36 is going to give me negative 28. So my standard form is going to be y equals negative 4x squared plus 24x minus 28. Remember, you want to FOIL this out first. I use a Punnett, then distribute the negative 4, the leading coefficient across, and then CLT with the constant term last. Rewriting it in standard form, again, I want to take the x plus 6 and square it. So I'm going to set up a cute little Punnett square. And I want to do x plus 6 times x plus 6. So x plus 6 times x plus 6. X times x is x squared. X times 6 is 6x. 6 times x is 6x. 6 times 6 is 36. I'm going to CLT, combine like terms. So that's going to give me x squared plus 12x plus 36. Now I have no number up front, so I just put the minus 7 into my problem. 36 minus 7 is going to give me 29. So this is going to be x squared plus 12x plus 29. And that's y equals. That's standard form. For number 20, I'm asked to rewrite it in factored form. So if you're not good at factoring, you might want to catch up on that skill. So y equals. Now, x times x equals x squared. If I were to reverse FOIL it. Now I need to know what two numbers multiply to equal 30. So 1, 2, 3, 4, 5. 30 divided by 1 is 30. 30 divided by 2 is 15. 30 divided by 3 is 7. 30 divided by 3 is 10. 30 divided by 4 is a decimal. And 30 divided by 5 is 6. The only two numbers that will reach 7 are 10 and 3. So I'm going to write down my 3. I'm going to write down my 10. Now I have to ask myself, which number is larger? Notice 10 is larger. So 10 is going to get this middle symbol. And this middle symbol is a negative. Now to figure out what goes here, you look at the both symbols. What's a negative times a negative? A positive. So there's the factored form. Which form is this equation in? This equation is in factored form. What are the x-intercepts for the parabola? So to find the x-intercepts, you're going to take the x plus 6 and set it equal to 0. Minus 6, minus 6. So one of the x-intercepts is negative 6. You're going to take the x minus 8 and set it equal to 0. So you're going to add 8, you're going to add 8. So x equals 8 is another x-intercept. Again, sometimes you're requested to rewrite it in this form as negative 6, 0 or 8, 0. They want it as a coordinate. What is the vertex of the parabola? There's a couple of ways to find the vertex. For this particular problem, I'm going to FOIL this out. So I'm going to set up a nice little Punnett square. And I'm going to put my x plus 6, my x minus 8, and I'm going to fill in the Punnett. X times x is x squared. X times negative 8 is negative 8x, 6x, negative 48. So I'm going to write that down with a 4 in front of it. 4 times x squared minus 2x minus 48. Now I'm going to distribute that 4. That's going to give me 4x squared minus 8x. And 4 times 48. 4 times 48. 4 times 48 negative, because it was a negative 48, equals negative 192. To find the vertex, you're going to want to use this formula called negative b over 2a. So negative b over 2a. So this is a, negative 8 is b, and c is negative 192. Negative b is going to be negative 8 over 2 times a, which is 4. So that's going to give me 8 over 8. So my vertex, the x value of my vertex, is going to be x equals 1. So right now I have the first part of my vertex. So it's going to be 1 comma something. To find out what the something is, I have to take this 1 and plug it in to this equation. I can plug it into the original factored equation also. It doesn't matter. So wherever there's an x, I'm going to plug in a 1. So I'm going to write it as 4 times 1 squared minus 8 times 1 minus 192. So I'm going to place that 1 in there. So this is going to give me a calculator key in of 4 minus 8 minus 192. And that'll give me the y value of my vertex. So 4 minus 8 minus 192 equals 196. So that's my vertex. So 1 comma 196. 1 comma 196. Is the parabola facing up or down? Because this is a positive number out front, the parabola is going to be facing up. Which form is the equation? So when it's in this form where it's got a quantity squared minus a digit, that's going to be vertex form. What is the vertex? I love when it's in vertex form. I just use this algorithm and I just say opposite, same. So the opposite of 6 is negative 6. The same as negative 3 is negative 3. So that's the vertex. Name the axis of symmetry. Notice once I have the vertex, the axis is the x value from the vertex. So the AOS, the axis of symmetry, is x equals negative 6. Is the parabola facing up or down? Because there's a negative sign out in front, it will be facing down. All right, y equals 2x squared minus 8x plus 5 First, they want to know if it opens up or down. Because this number out front is positive, that means it's going to open up. Now, to find a vertex, I'm going to do negative b over 2a. Now, if you look at this, a is going to be 2, b is going to be negative 8, and c is going to be 5. So negative b would be negative 8 over 2 times whatever a is, and a is 2. So that's going to give me 8 over 4. 8 over 4 means my vertex is going to have an x value of 2. Now I want to take that 2 and plug it back into this equation. So 2 times 2 squared minus 8 times 2, times 2 plus 5. So I'm going to plug that 2 that I got from 8 over 4, which equals 2. I'm going to plug that 2 back into this equation. So 2 squared is 4. 4 times 2 is 8. 2 times 8 is 16, or 8 times 2 is 16, so it's going to be minus 16 plus 5. Now I'm going to jam that into my calculator to get the value of 8 minus 16 plus 5. So 8 minus 16 plus 5 equals negative 3. So my y value for my vertex is negative 3. What I like to do, 1, 2, 3, 4, 5, is go right in the middle and put my vertex to negative 3. And now I'm going to be looking for values above it and below it. So the value below it and above it is going to be 1 and 0, and then 3 and 4. I'm going to plot my coordinate to negative 3. So I go right, 1, 2, and I go down, 1, 2, 3, and that's my vertex. All right? Now I have other information. See this 5? That 5 is also my y-intercept. 1, 2, 3, 4, 5. And I pop a dot there. So that's my y-intercept. I'm going to graph it and watch. So I like to write down whenever I have a parabola, whenever I have an x squared, I like to write these numbers down. 1, 3, 5. They're magic numbers for a parabola. And my a is 2. So I'm going to put my 2 out in front of 1, 3, 5. So that means my vertical stretch is 2. I'm going to go 2, 6, 10. So from here, I'm going to go up 1, 2 over 1. That's a coordinate on my parabola. From there, I'm going to go up 6. 1, 2, 3, 4, 5, 6 over 1. Notice how it lands on that y-intercept. Now, I don't have enough room to go up 10 over 1. So I'm going to go back down to my vertex, and I'm going to implement 1, 3, 5, but with the 2 out in front. So 2, 6, 10. So from here, I'm going to go up 1, 2 over 1. Then I'm going to go up 1, 2, 3, 4, 5, 6 over 1. And that's the shape of my parabola. Now I can answer these questions. So when x equals 0, y equals 1, 2, 3, 4, 5. When x equals 1, y equals negative 1. When x equals 1, 2, y equals negative 1, 2, 3. When x equals 3, 1, 2, 3, y equals negative 1. And when x equals 1, 2, 3, 4, y equals 1, 2, 3, 4, 5. And notice these numbers are going to bounce. What is the axis of symmetry? Well, the axis of symmetry is the x value from the vertex. And notice the x value from the vertex is 2. So the AOS is going to be x equals 2. Remember, axis of symmetry and vertex, those x's remind me that it's going to be x equals that x value. Okay, for number 30, I love when I'm given a parabola in vertex form. So I immediately go to my vertex, and I know it's going to be opposite, same. So the opposite of 1 is negative 1. And the same as 5 is going to be 5. So I know right now, 1, 2, 3, 4, 5. The middle one is going to be negative 1, 5. Notice it's negative 3 out front. So that means my parabola is going to open down. My AOS, my axis of symmetry, this x and this x reminds me that it's going to be x equals that negative 1. I'm going to plot my vertex at negative 1, positive 1, 2, 3, 4, 5. I'm going to pop a dot there. Now, I can't get the y-intercept from that 5 because it's in vertex form. So I actually have to figure out what these coordinates are going to be. Now, pay close attention. Because it's x squared, I'm going to write down 1, 3, 5. But notice, there is a negative 3 in front of my problem. That's why it opens down. So I put that negative 3 out in front of my 1, 3, 5. And that's going to be negative 3, negative 9, negative 15. So the array of coordinates from that vertex, from here, I'm going to go down 1, 2, 3 over 1. Pop a dot. From there, I'm going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Takes me off the drawing almost. Over 1. Go back to the vertex. Go down 3. 1, 2, 3 over 1. Go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And now I can sketch my parabola nicely. One, 3, 5 is very powerful. Now I have my graph. I can plot my coordinates. I can write down my coordinates for my table of values. So I'm going to go below and above. So below negative 1 is negative 2, negative 3, 0, and 1. So at negative 1, 2, my value is 1, 2. So at negative 2, 2. At negative 1, 2, 3, I have to find that coordinate way down here. So I'm going to find out what that coordinate is to write it in. So at negative 1, 2, 3, I go down 1, 2, 3, 4, 5, 6, 7. So it's going to be negative 3, negative 7. At 0, my value is 2. And then I don't even have to look at the graph. See how 5 is in the middle? 2 is above and below. That means negative 7 is going to be above and below. Negative 7.